So I'm sure you've been dying to know, how do you factor these polynomials if there is no greatest common factor? Well, good news is there's many ways. And this video is going to talk about one other possible way. It's not the be-all end-all, it's not the only other way, and it's not going to work in every case, but this is the next video in this line. So, we're going to talk about factoring trinomials, so it has to be a trinomial, where x squared plus bx plus c is the form we have. That means we need to remember standard form. Ax squared plus bx plus c equals 0. So the factoring is all going to be done when we have it equal to 0. But the other thing that's going to be key, this method is only valid that we're learning today if a is equal to 1. So that's why up here we just have x squared, not ax squared. And this is the first day where these box problems are going to make a big difference and going to really play a huge role. So you have to remember that these mean we have to multiply to whatever number's on top and add to whatever number's on the bottom. So the way I do this is take that 6 and figure out what multiplies to 6. Well, that's 1 times 6, or it's 2 times 3. Problem is, if I add these, 1 plus 6 is 7, 2 plus 3 is 5, nothing adds to negative 5. So you got to put your thinking cap on and remember, negative 1 times negative 6 also multiplies to 6. So your negatives matter here. So does negative 2 and negative 3. Now when I add, this gives me negative 7, this gives me negative 5. That's the key. Negative 2 and negative 3 multiply to a positive 6 and add to a negative 5. Those are the two major things that we're going to be focused on as we look into this new way to factor our polynomials. So the directions will typically just say factor completely. We're not going to have any more detailed directions than that. And we look and we see that we have first and foremost a trinomial and that it's in standard form. As long as that trinomial is in standard form, we want to do a box problem. Now, how do we do what we call box problem? When we have this, it's all about identifying B and C. Because as we do these box problems, we're always going to put C in the top and B on the bottom. And then I'm going to call these here F1 and F2. Those are my factors. So step 3 is going to be writing our two binomials. X will always go first, and then those factors will go second. So, example. This problem is already in standard form. X squared plus bx plus c. And we know a is 1, b is 8, c is 15, so we're going to set up a box problem. And I'm just using x, I don't need the entire box. C always goes in the top, 15. B always goes in the bottom, 8. I need to know what multiplies to 15 and adds to 8. So I look to see what multiplies to 15. 1 times 15. Now if you don't know these, take your calculator out and just start dividing. 15 divided by 2. If you get a decimal, don't put it on your list. 15 divided by 3. And keep going in order. Oh, 3 is 5. So 15 is 3 times 5. 15 divided by 4. Decimal, don't put it in your list. Good news. You already have 5 on your list. You don't have to keep checking. You know 5 works. It's 5 and 3, and you don't have to repeat numbers. Then just check. What adds up here? This adds to 16, not my answer. This adds to 8, that's my answer. Positive 3, excuse me, and positive 5. 3 times 5 is 15, 3 plus 5 is 8. Those are my factors. They go in my binomials. Now, why is it x here and x here? Because it's x squared. X squared is x times x. Those go here and here. Those are the only two factors of x squared. Okay. Why do I have two numbers second? Because it's 15. I need the two numbers that multiply to 15, but there could be multiple. There are. And so this process here is finding which two numbers go there that multiply to 15. There's only one option for x squared. It's x and x. So which option do I use for positive 15? In this case, it's plus 3, positive 3, and plus 5, positive 5. Done. Factored into two binomials. I could now distribute the double distributive property to check. I should get back to x squared plus 8x plus 15. If I don't, I made a mistake in my factoring. So let's look at another one together. It's already in standard form. B is negative 9 and C is positive 20. So I set up my box problem. C on top, B on the bottom. What multiplies to 20? That's 1 times 20. That's 2 times 10. Again, if I want to keep checking, I can keep checking. 20 divided by 3, decimal doesn't work. 20 divided by 4, oh, it's 5. So it's 4 times 5. And I already have 5. I don't have to check it. Now I check my addition. 21, 12, 9. None of it works. But then, again, just like before, we have to consider negative times negative is a positive as well. And you should look and see, hey, I need negative 9, but I got positive 9. Oh, wait a minute. If I change these both to negatives, I'm going to get negative 9 when I add. And negative 4 times negative 5 is equal to positive 20. There's my factors. Negative 4 and negative 5. The order in which I write the factors doesn't matter. The fact that they're negative does. So again, my binomials. X squared is just x times x. That's first. Positive 20. Which factors do I use? I have a whole list of them. I use these factors. Minus 4 and minus 5. Since they're negative, it's a subtraction problem. There's my binomials. Okay, on the back, same idea, different concept though, because first, this is not standard form. We have to do this once it's in standard form, so I have to rewrite this. Now, rewriting is different than solving. Okay? To move my x squared first, I just consider the fact that it's a positive x squared. And I just write it as a positive x squared. My 8x has to be second. It's negative. My 9 is last. It's negative. Now I'm in standard form. Now I know that B is negative 8 and C is negative 9. So in my box problem, what multiplies to negative 9 adds to negative 8. Well, if I'm multiplying to a negative 9, 1 and 9, but one of these has to be negative. So what I want to do is check both of these options. 1 times negative 9 is negative 9. Negative 1 times 9 is negative 9. Okay. If you see your factors, you can stop. You don't have to keep going. Okay. But I would keep going here. 3 times negative 3. Well, I don't need to write negative 3 times 3. That's the same thing. So now I check my addition. This adds to negative 8. This adds to positive 8. And this adds to 0. I needed negative 8, so my factors are positive 1 and negative 9. It matters which one is positive and negative. If I use negative 1 and positive 9, it does not add to negative 8. It adds to positive 8. So my factors are x plus 1 and x minus 9. Again, the x comes from the x squared. The 1 and 9 come from the 9. Positive negative comes from the negative. Those are my factors. Which order I write this in does not matter. It could be x minus 9, x plus 1, or x plus 1, x minus 9. The plus 1 and the minus 9 do matter. I want you to press pause and try the last one. Again, it's not in standard form, so make sure you put it in standard form first. Hopefully this is our standard form. If it's not, correct it and go back and fix your answer. So what multiplies to -18 and adds to +3? So the option that works here is -3 and +6. -3 and +6 are my factors. I get x for my x squared -3, and I get x plus 6. I need the parentheses. It's multiplication. Those are my two binomials.